Assalamualaikum warahmatullahi wabarakatuh. To our lecturer IR Mazlan. I am Muhammad Sadiq bin Muhammad Salahuddin from 2 BMMA section 1/2. So today I am going to present to you about torsional loadings evaluation, which is our mini project. So first things first, the objective of this project is to extract free body diagram from the actual structure. So when we have an actual structure, when we want to calculate the torque and moment and equation of equilibrium, we need to have the free body diagram in order to calculate it more accurately. And then also we have to assess torsional loadings from the real structure. So by we do this torsional loadings evaluation mini project, we can assess the torsional loadings. And also the objective of this project is to discover maximum force shaft able to withstand. So by doing this evaluation, we can determine what is the maximum force that the shaft will able to withstand. So if the load is higher than it is supposed to withstand, it will cause permanent plastic deformation. So it is also, the objective is to determine the allowable force from the factor of safety. So by getting the factor of safety, we can determine the allowable force. So for our mini project of torsional loadings evaluation, our group decided to use lug wrench as our structure. So a lug wrench is the name of a type of socket wrench used to loosen and tighten lug nuts on automobile wheels. So it is the wrench that is used to tighten and loosen the nuts on the tire, so that we can remove the tire and then we can replace the tire. So the material property of our structure is, it is of course stainless steel. It is also the yield strength of it is 215 megapascal. So we can search in the internet and we can get it. The modulus of rigidity is 77.2 gigapascal. That is also we can get it from the internet. So the ultimate strength of our lug wrench is 505 megapascal. So for the dimension, as you can see in the free body diagram, the length whole from point A to point C is 600 millimeter. So the reason why we divided at the center, because the pivot point is at the center. The pivot point is the point that where the torsion, the twist happens. So because the lug wrench is like this, so we twist like this, so it is at the center, right? So that's why it is called the pivot point, and that is why we divided the length by 2. So we take the length as 300 millimeter. So for the load, it is 70 Newton. So the load is 70 Newton, and also the diameter of the shaft is 20 millimeter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Haikal bin Muhammad Zaidi, and I will talk about the calculation. From free body diagram, as we can see, we find the internal torque in the arm by using the equation of equilibrium. Then the pivot point is at the center. We use submission moment equal to 0. Then we substitute the value. Then we got the internal torque is equal to 42 Newton meter. Then we find the polar moment of inertia J. J equal to pi over 2 times C power of 4. Then we substitute the value. We got 1.5708 times 10 power of negative 8 meter power of 4. Then we can find the angle by using angle of twist equation. That is equal to torque times length over polar moment of inertia times modulus of rigidity. Then we substitute the value. We got 0.0104 radian, and we convert into degree. We got 0.596 degree. Next step, we can find the maximum shear stress by using the equation torque times C over polar moment of inertia. Then we substitute the value. We got 26.74 megapascal. And we can find the maximum torsional deformation by using the equation C times angle of twist over length. And we substitute the value. We got 0.00035 radian. And we convert into degree. We got 0.6 0.0201 degree. Then we can find the allowable stress by using factor of safety formula. The formula for factor of safety is ultimate stress over allowable stress or yield stress over allowable stress. First, we need to convert to shear properties. Shear yield strength formula is 0.5 times tensile yield strength, and we got tensile yield strength is 215 megapascal, and we substitute into the formula, we got 1.075 times x pascal or 107.5 megapascal. And after convert to shear properties, we can substitute the value of shear yield strength into factor of safety formula. As we know, FOS is 2 based on table 1. Then we can substitute, we got allowable stress is 53.75 megapascal. And lastly, we can find the allowable force by using the formula P over A. The area we can find by using pi r square. Then we got the value 3.142 times 10th power of -4 meter square. Then we substitute the value into the formula. We got the allowable force is 1.69 times 10th power of 4 kilonewton. That's all from me. Thank you.
So for the discussion, we take the factor of safety value is 2, because based on the table we can see for tools structure it is always more than 1. So you can take 3, you can take 4, but we as a group decided on 2. So the contextual investigation was done completely through theory calculation, with the exception of structure that is real life. The only thing that is real is the structure. Everything we calculate is in theory. So by this way, the information we gathered perhaps not very accurate. It is in theory and it's not in real life. So it is not accurate because when you compare real life data obtained by calculating practically and with calculating theoretically, you can see there is a difference, as that is not accurate enough. So finally, for the conclusion, we can see that based on this mini project, we can conclude that the Lagrange structure optimal working condition is below 53.75 megapascal. It is the allowable stress. If the Lagrange is subjected to more than 107.5 megapascal, then as I said in the objective, then permanent plastic deformation will possibly occur due to the overload. So that's all from us, and thank you for staying with us, and don't forget to subscribe our channel.